CPU scheduling. CPU scheduling. Scheduling refers to selecting a process from many ready processes that is to be next executed on CPU. In multi-programming environment, multiple processes are kept in main memory. When one process has to wait for input-output completion, operating system takes the CPU from that process and assigns it to another process. In this way, CPU is never ideal and has some process to work on. Scheduler. A scheduler is an operating system module that selects the next job or process to be assigned to CPU. Thus, scheduler selects one of the many processes in memory that are ready to execute and allocates CPU to it. A scheduler is of three types: the long term, the medium term, and the short term. Long-term scheduler. Long-term scheduler selects the processes from secondary storage and loads them into memory for execution. It is called long-term because the time for which scheduling is valid is long. The frequency of execution of a long-term scheduler is usually low, as there may be minutes between the creation of new processes in the system. The primary objective of long-term scheduler is to control the degree of multi-programming. Degree of multi-programming refers to the total number of processes present in the memory. If the degree of multi-programming is stable, then the average rate of process creation is equal to the average terminate rate. This scheduler shows the best performance by selecting the good mixtures of input-output bound and CPU bound processes. Input-output bound processes are those that spend most of their time in input-output. CPU bound processes are those that spend most of their time in computations. Medium-term scheduler. The medium-term scheduler is required at a time when a swap-out process is to be brought into pool of ready processes. A running process may be suspended because of input-output requests. And such a suspended process is then removed from main memory and stored in secondary memory. This is done because there is a limit on the number of active processes that can reside in main memory. Therefore, a suspended process is swapped out from main memory. And some later time, the processes can be swapped into the main memory. All versions of Windows use swapping. And short-term scheduler. Short-term scheduler selects one process from many ready processes that are residing in main memory and allocates CPU to one of them. Thus, it handles the scheduling of the processes that are ready state. Short-term scheduler is also known as CPU scheduler. As compared to long-term scheduler, a short-term scheduler has to work every often. The frequency of execution of short-term scheduler is high. It must select a new process for CPU frequently. Let's proceed to preemptive and non-preemptive scheduling. A scheduling algorithm can be preemptive scheduling and non-preemptive scheduling. Non-preemptive scheduling. A scheduling is non-preemptive if, once a process has been given the CPU cannot be taken away from the process. In other words, in non-preemptive scheduling, once the CPU has been allocated to a process, the process keeps the CPU until it releases the CPU either by terminating or by entering the waiting state. Preemptive scheduling. A preemptive scheduling or a scheduling is preemptive if the CPU can be taken away from a process after being allocated. In other words, even if the CPU has been allocated to a certain process, it can be snatched from the process anytime either due time or constraint or due to priorities reason. Dispatcher. Dispatcher is a program responsible for assigning the CPU to the process which has been selected by short-term scheduler. Dispatching a process involves and context switching. Scheduling criteria. The goal of scheduling algorithm is to identify the process whose selections will result in the best possible system performance. The various scheduling criteria for evaluating an algorithm are discussed next. Scheduling criteria. CPU utilization. CPU utilization is the average fraction of time during which the processor is busy. The level of CPU utilization depends on the load on the system. And CPU utilization may range from 0 to 100%. Throughput. It refers to the number of processes that system can execute in a period of time. For long processes, this rate may be 1 process per hour. For short processes, throughput may be 10 processes per second. And thus, evaluation of throughput depends on the average length of a process. Turnaround time. This is the interval of time between the submission of a process and its completion. Thus, turnaround time is an average period of time it takes a process to execute. Turnaround time includes actual execution, time plus time spent waiting for resources and doing input-output. Thank you. Have a nice day.